Hey guys, this is an example for, this is a video for examples of exponents. So I'm going to solve some of these. Please do take good notes and keep them ready for reference when you're doing the worksheet and the work from the textbook. So let's look at the first example. So what do we have here? We have some numbers, 2 and 3, and we have exponents, the a to the power 2, a to the power of 5. So numbers, 2 times 3, the numbers that is 6. And a to the 2, a to the 5, we have to do a to the 2 plus 5. And so that is equal to 6a to the 7. So notice here, the numbers are simple, straightforward multiplications and divisions that you're going to see. You don't do anything beyond that. But the exponents, when it comes to exponents, you're going to apply the power rule, the quotient rule, or the product rule. Okay. Let's look at the second example. Let's look at numbers first. 15, negative 5. When you divide 15 by negative 5, you will get negative 3. And you have c to the power of 7, c to the power of 4. So because it is a quotient, you'll have to subtract 7 take away 4. 7 take 4 is a 3. And in this example, the third one, we have a exponent here, x to the power 3. There's a number there, and there is a power 2 there. Okay, so the 3 here is being raised to the power of 2, 3 to the power of 2, like that. And then we have the x to the power of 3 and 2, and remember it's a power of a power. So if you use power rule, it is 3 times 2, that would be a 6. 3 to the power of 2 is a 9, 9x to the power of 6. Okay, here avoid this mistake. Okay, oftentimes people think that it is 3 times 2, and instead of having a 9 there, they will have a 6. I've seen it too many times. I hope you remember this very important point here. Number 4. Number 4, we have a power rule, that is a 3 here, and you have a quotient as well. So let's do the power rule first. And so what we do here is negative 2 to the power of 3. And since we don't have a power, we can assume the power to be a 1. So it is x to the power of 1 times 3. We have to multiply that. So 1 times 3 is a 3 itself. This divided by 2x squared. So negative 3 to the power of 2. Negative 3 to the power of 2. So that would be, let me put it over here for you. Negative 2 to the power of 3 would be negative 2 times negative 2 times negative 2. So you're multiplying it 3 times. Negative, negative, negative will give you a negative. 2 times 2 is 4. 4 times 2 is 8. So I have negative 8 x to the power of 3 divided by 2x squared. Okay, handle the number with the numbers. So that and that. Negative 8 divided by 2 is a negative 4. And then now handle the exponents. Now this is a quotient rule. X to the 3 divided by x to the 2. 3 take away 2 is a 1. You don't have to write the 1. Okay, it's all right if you don't write the 1. Okay, what about this example here? We have grouped the x with the x. Okay, even though they have negative exponents, it still doesn't work. It still works exactly the same way as your regular product rule would. So you're adding those two. And then so y squared, y to the power of 3 would be y adding those two. So what do I have for the x here? Negative 3 add a 1 is a negative 1. And for the y, we have 2 take away 3 is a negative 1. And here, these are negative exponents. Now, you can never leave the negative exponents as it is. You should change them to positive. And remember, if the negative exponents are in the numerator, you can take them down to the denominator and then make it positive like that. You don't have to write the 1, I'm going to do it in the beginning for you to guys to get used to. Okay, if you're confused about this particular rule, go back and watch the previous videos. Watch it a few times till you get familiar with it. All right. So coming to this example number 6, the -2, the power is negative. So take it to the denominator like that. Now the power now becomes a +2. And then what we have here, 3 to the power of 2 is a 9. Now x to the power 2, it's a power of a power. So we're going to multiply 2 times 2, and that's going to make it 4. And then when there is no power for the y, assume the power to be a 1. It is 1 times 2 now, and that is your final answer. Example 7. Now, example 7, it has a to the power 0, and we know that a to the power 0 is a 1, so that goes away. So what do we have? A to the power 0, x. Now, the y, see this here? This is a negative exponent. So what we're going to do is, because it's a negative exponent, we are going to take it to the denominator and becomes positive. Now here, the xy to the power of -1, it's a negative exponent in the denominator, so it's going to go to the numerator like that, and it's going to become a +1. Now we have gotten rid of all the negative exponents first. It's a good idea to do that when you're multiplying and dividing, because it's a lot simpler to work with like that. So I'm going to rewrite the same thing again so that it looks a little better and you will understand this a little better. And I made a mistake. So this is a xy, so that is a xy, and then I have a y squared. So what do I have here? In the numerator, x times x is a x squared y, and the denominator has a y squared. Now I'm going to make a shortcut for you guys here, okay? So here, I'm going to say there are two y's in the denominator. Y to the power of 2 is y times y. There is one y in the numerator, so I'm canceling that out. That leaves me x squared over y. Yes, you could have applied the quotient law. You will get the same answer, but I'm trying to introduce something to make your life a little easier. Hopefully in class when we meet, we can have more examples that we can cancel terms out. Okay, see you in the next video.